Okay, so these were the measurements that I got based on measuring the sides. Okay, if another triangle of the same shape has another triangle of the same shape, so like exact same, like that looks like that, has a perimeter that is doubled, what effects do you think it will have on the area? So Nikki says, I think it will double too. I heard you say it to Taisha.
I say stuff sometimes that I don't.
It's okay. I love the discussion that you guys are having because it's a hypothesis. And to make you feel better, Taisha agreed with you. Huh? 2 A's and 2 E's?
No.
Oh, just two A, 1 E. Okay. I just called you Taisha. Okay. That's what a hypothesis is. It's like a guess. I don't need you to calculate it and then tell me the answer. That would be solving, right? And then my second hypothesis is if it's halved, Eiko thinks that the area will double. Okay, so those are the two hypotheses. Let's try it. Let's work it out. See if we are right or wrong, or right on the spot or way off. Okay, so this was the given one. I just redrew it so that we can see it side by side. Okay, of course, these are not to scale. Okay, one thing that I want to ask Taisha, since you proved it, if I double the side lengths, what's my height here? So here, if I double my side lengths, what happens to my height as well? It also doubles. So this is 10. Yeah. Then what about if it's half? If I halve each of the sides? Yes, 2.5. So believe it or not, yeah, when you shrink the whole triangle, the height also shrinks in the same proportion. Yeah, all right. So let's try to figure out the area. Eiko, what is the formula for area of a triangle, please? Thank you. Yes. Base times height divided by 2. So in this given one, 7.5 times 5 divided by 2, we get 18.75. What's my unit? Centimeter square. Area. Square. Okay. What if you double all the sides? Now my base is 15. My height is 10. And I divide it by 2. So 750 divided by 75. No, wait. 150 divided by 2, you get 75 centimeter square. Is this double this? How many times more is it? To figure out how many times more, you would do the bigger number, divide by the smaller number. Whoa. And you get 4. So 4 times as big. So, sorry, Nikki and Taisha. It's actually not double. It's 4 times as big. Okay. So let's see what happens with half then. Let's see if Eiko is right. If this is 4 times, does that mean this is 2 times? Well, my base is 3.75. My height is 2.5 divided by 2. 3.75 times. Oh, actually, I didn't. I get 4.68 centimeter square. Compare this with this. This with this. What's the connection? All right, what's the connection between this area and this area? What is it?
I also shot 4 times.
It shrunk 4 times, right? So in other words, if this is times 4, this was a fourth of it. Yeah. Does that make sense? And when you think of an area, remember the bigger the triangle, the bigger the area. The smaller the triangle, the smaller the area. So in this case, nope, it didn't double. It actually shrunk by 4. So you actually times it by 1/4. Okay. So does that mean if I now want to do a triple, a triangle that's triple, it's also times 4. If I do a triangle that's 100 times bigger, does that mean it's the area is also times 4? That's just like what I just said. The bigger your triangle, the much bigger your area. So where did this 4 come from? All right. We will find out in the next episode, which is tomorrow. To be continued. Yes. So tomorrow we will find out where that came from. All right. What are we going to focus on today then? Is similar triangles, properties of it, naming it. Okay. So 2 triangles are said to be similar. Oh, so let me go back to this. Why we can compare these is because these are all similar triangles. Okay, what are similar triangles? Similar triangles have angles that are equal. Okay, do sides have to be equal? No, sides have to be proportional. Make sure you read this word proportional, proportional, proportional. Those are the two key words. You're going to use it like for the whole chapter. Done? Question? Skip to the next question first? Or you don't have any more questions? Is there another one that you can go to first? Oh, okay. So just hang in there for 1 more minute. Okay. So according to this figure, angle A is equal to angle P. So this angle is the same as this angle. Angle B, I'm going to match it up with angle Q. So this angle matches with this angle. And angle C matches up with angle R. Okay. So on the test, you can either use color codes or you can use single lines to show, double line, triple line. Okay. What do you notice about the alphabets that I use? What do you notice about the alphabets that I use for angles? Okay. What's anything else you notice about the letters? It doesn't have to be. All right. They're all angles are capital. We always use capital for angles. Okay. So what do you think we use for lowercase? Which are? What's in the triangle that's not angle? Side lengths. Side lengths. Lengths are lowercase. Okay. So for example, angle A, capital A. The side opposite to it, this is lowercase a. Angle B is capital B. Opposite to it is lowercase b. And angle C, capital C, opposite side is lowercase c. So the length of C is 8 centimeters. Length of B is 4 centimeters. Length of A is 6 centimeters. So forth. Okay. The letters does matter. So make sure angles, capital, lengths are lowercase. And if you say this is angle B, this has to be length B. Okay. So it has to match up. similar triangles, we use this squiggly line. The squiggly line means that they are similar. Okay. So, since we said corresponding sides are proportional, AB, that means this side is AB. So this side is, when I compare it with this side of the similar triangles, that ratio is the same as BC over QR. So they hold the same ratio. Okay. Remember AB, I can write it either like this. So when I write it like this, even though I use capital, I'm saying from this vertice to this vertice. So from angle A to angle B, this line segment right here. Okay. Other than calling it AB, I can call it lowercase c over lowercase r. I can call BC lowercase a over lowercase p. And then the other side, AC, I can call it lowercase b, and PR, I can call it lowercase q. Okay. So let's. What is how long is how long is length C? Yep, 8 centimeters. How long is R? Yep, 4. So 8 divided by 4, you get a ratio of 2, which means every single one of these sides has a ratio of 2. And it's right? 2 times 2 is 4, 4 times 2 is 8, 3 times 2 is 6. So that's what it means by proportion. Every single side is multiplied by the same amount or divided by the same amount. Okay? Proportion means you're multiplying or dividing the sides. Okay? You never add or subtract. Never add or subtract. I see people like say, okay, so since this is 4, that means this is 6, and then 4, and then 5. Never add or subtract. Multiply or divide. Multiply or divide. Multiply or divide. Okay? So, similar triangles have equal angles. We know that. Yeah, similar triangles, equal angle. Similar triangles, their sides are proportional. So not the same, but proportional. Same ratio. Congruent triangles. What does the word congruent mean? What's another word for congruent? Another word for congruent? Yeah. Same, yeah. Congruent just means same. Yeah, so same triangles mean that it's the same triangle. So imagine like if two triangles have the same angles and same length, they are literally the same triangle. Okay, and then same triangles, are they similar? Can we say these two same triangles are similar? If two triangles are identical, can I say they are similar triangles? Because remember the condition. The condition was angles have to be the same. Yeah. And lengths are proportional, which is 1 times 1. All right. What about the reverse? Are all similar triangles congruent? No. Similar triangles, one could be really big, one could be really small. Then definitely they're not congruent because they're not the same. All right. So this is a good true-false question. Okay. Congruent triangles are similar, but the converse is not always true. Okay, so take 2 minutes, fill this out. I'm just gonna answer Ivy's question. Take 2 minutes, fill out 1, 2, 3. So fill in the blanks. Two triangles are similar if their corresponding angles are equal. Good job. Two polygons of the same number of sides are similar if their corresponding angles are equal again. Yeah, and their corresponding sides are proportional. You know how I kept saying at the beginning? Those are the two words that you will use again and again and again and again and again. Yeah, there you go. Given triangle ABC and XYZ are similar. So these two are similar. Angle C is equal to which one? Which one? This angle right here. Angle C. Which one are you going to match it up to on the side? Angle C is Z, yeah. Okay. Victor, how did you know it's Z?
Because it's like the same triangle, but it's like flipped.
Okay, yeah, so you could rotate this. Remember, like the what they told you is the angles are the same because they're similar. So this 75 matches up with this 75. This 80 degrees match up with this 80 degrees. And so Z matches up with C. Imagine like you rotated this like this. Okay, so angle Z. What about length BC? Length BC right here. BC. Which side does it match it up with on this triangle? Victor? ZY. Yeah. Does the order how you say it matter? No, doesn't matter. This one it doesn't matter. You can say YZ or ZY. Your line from left to right or right to left is still the same line. So this case it didn't matter. Okay, and lastly, XZ. 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 AC, yes. AC. All right, so for all of these, you could rotate it if you need to. You could redraw it if you need to. But most importantly for today's lesson is to make sure that you know which side goes with which side. You know how to compare. So for example, right here. So this triangle, if I rotate my paper, all right, you can see, right? Now it's a little easier than seeing it like this. So, okay, so I'll leave the backside to tomorrow because we have lots of time. For now, for the last 20 minutes, you can either work on page 333, 458, okay, which is focusing on naming the angles, matching up the sides, properties of similar triangles. Or if you want to work with your partner and do this at home for homework, you can do that too for the Demo project. Okay, sounds good? All right, so let's work on this. We'll do the second half of the lesson tomorrow.